So cabling, basically we have a types based on distance, based on cables and based on duplex, right? The developers of Ethernet had some additional decisions to make. That is, maximum speed would be, originally it is 2.94 Mbps, that is some millions of bits per second, right? And maximum distance of transmission will be only 100 meters. They decided with the bodies, as I told you already, IEEE, right? IEEE, IETF, and in the beginning I have shown you. These guys, they have come to a conclusion and made these decisions that maximum speed would be 2.94 Mbps. Okay, and the maximum transmission distance without any repeaters would be 100 meters. And what type of cable would it be? It would be copper coaxial cable. I shown you the cables, right? Yeah. Coaxial cable, fast Ethernet cable. These are some decisions taken by these bodies at that time, or we can say these are the by default values. This is the Ethernet frame structure, that is data link layer header. Simple. Okay, it has preamble, it has destination address, source address, type. This is the data which it received from the network layer, and this will be the FCS. As I told you already, this will be the, it will be working like 6. Yeah. Right? And the header size of this header size will be, excluding this, will be 18 bytes. Okay, we don't include this also. Only from here to here plus here to here. It will be 18 bytes. If you include this, then it will be varying from 64 to 1518 based on the data. Based on the data. Whatever the data is received, 18 bytes of header is added. Okay. Whatever the data is received, 18 bytes of header is added. Just remember this, just don't go in depth. Header length is 18 bytes. Whatever the data is received, 18 bytes of header is added. Okay? Done. Now, destination MAC address you know, source MAC address you know, type I already told you. It will tell which upper layer protocol is used and to which protocol should I deliver this data. In order to know that, we use type, as I told you already. Data is data, FCC is working like. This is Ethernet header. We also have another header, that is 802.3 header. Everything is same. Destination, source, length will say the length of this data. FCS, FCS. Preamble. Preamble is to tell device that, or to synchronize the clock rate of router to the header's clock rate. Okay, you don't need to take much care of it. Okay, just remember destination address, source address, type, data, and FCS. Yeah. So MAC address, media access control. It is of 48 bits. It will be denoted as 48 bits, 16 bits with dotted decimal, 16 bits with dotted decimal, and some, if you consider Microsoft, it will be 2 bits Microsoft, 2 bits Microsoft. This will be an hexadecimal, like this, right? First 24 bits considered as OUI, and remaining 24 bits are vendor assigned. That is, if you are considering 48 bits, out of 48 bits, first 24 bits will be assigned by, it will be global unique identifier, that is assigned by Again, the IEEE or IANA or some other body will assign every vendor a unique identifier. Okay, every device a unique identifier is assigned by IEEE standard bodies. For example, think IEEE, and remaining 24 bits will be vendor assigned. That is, HP will have, what is this, HP or Dell? Toshiba. Toshiba will have one vendor 24 bits MAC address, 24 bits. Acer will have one, HP will have one, Dell will have one. Okay, so MAC address is divided into two portions. Half of the portion will be of globally unique identifier, and remaining 24 bits will be of vendor identifier. So this is the thing I told. OUI, which is a global assigned by IEEE, and this will be unique within organization. That is, if you are buying a Dell, Dell will have one thing, HP will have one thing. What else? Acer will have one. Where is it? And two bits of fast byte are very important. That is, bit number one LSB, bit number two global or local. This says very simple here. See, bit 1 and 2 LSB. This says whether it is individual or group or addresses. See, if this bit is 0, if this bit, the first bit, that is LSB bit in the first byte, for suppose this is my first byte, right? This is my first byte. If it is 0, this bit is 0, then it is unicast. If it is 1, then it is either multicast or broadcast. Bit 1 LSB. And bit 2, it will tell whether you have changed any MAC address. If you change your MAC address, how the body, whatever the local body is there, how does it come to know that you have changed your MAC address? That is by this bit. If you change your MAC address, it will be local 1, and if you are not changing, it will be 0. It will be global unique. So Ethernet cables, it is not, it is important, but you can read it very. Uh, as we know, we have 8 cables. Every 2 cables will be twisted like this. Same. And see here, one standard designed by bodies is, see here we have transmission 1, transmission 2, receiving 1, receiving 2, right? Actually, we have types of cable based on duplex, that is straight cable, straight through, crossover, and rolled. Okay, straight is like directly my TX1 cable, which is connected to my TX1, will it directly be in the straight way, it will be connected to RX1 of the other device. Actually,
So they were across exponential different devices. One device are different.
yeah, that is the thing, that is the thing. If you consider switch, it will have first receiving. Actually, you have 8 cables, right? 1 2 3 4 5 6 7 8. You'll have 8 cables in general Ethernet cable. First cable will be receiving 1, right? Second cable also will be receiving 2. Third cable will be transmitting. That through that wire, switch transmits. That pin, whichever connected to that cable, third cable, it will be transmitting. So it will be transmitting. Fourth will be dumb. Fifth will be dumb. Sixth will be transmitting 2. and again 7th will be 8th will be dumb. That is for other purposes. Where in switch, okay, my PC, my PC. First will be transmitting, second will be transmitting, third will be receiving, fourth and fifth will be dumb, sixth will be again receiving, and seventh and eighth will be dumb. These are for other purposes. Okay.
Then it's the opposite. Receive.
Yeah. Now, if I want to communicate between switch and PC, I will connect it to straight through cable. Okay, because directly my receiving bit of my switch is connected to transmission bit of my PC. It can be directly connected. There will be no problem, right? Right. So this will be straight. So it is straight through.
Yeah.
But if you are considering crossover, if I want to connect one switch to other switch, at that time it will be receiving one, receiving two. This will be transmission one, dumb dumb. Again transmission two, dumb dumb. If I want to connect one switch to other switch, okay. If I connect through straight through cable, this is the receiving end and this is also receiving end. This will be the transmitting end and this will also be the transmitting end. Very simple. If I am giving you, you should take it. And if you are giving me, I should take it. But I am giving you and you are giving me, what will happen? The same phenomenon apply here. Okay. So what happens is straight crossover is receiving one will be connected to transmission one. Receiving two will be connected to transmission two. Transmission one will be connected to receiving one. Transmission two will be connected to reception two. By this, what happening? Cable is not going straight. It is crossover. That is why it is crossover and it is straight. And we have one other thing, rollover. That is very simple. One, two, three, four, five, six, seven, 8. In rollover, what happens is 8, 7, 6, 5, 4, 3, 2, 1. What happens is 8 will be directly connected to, 8 will be connected to 1, 7 will be connected to 2, 6 will be connected to 3, 5 will be connected to 4, 4 will be connected to 5, 3 will be connected to 6, 2 will be connected to 7, 1 will be connected to 8. You are getting it, right? One pin is connected to 8th pin of the other device. That is rollover. Completely from one end to the other end. That is rollover. If you see the image, you can better understand it. See, 1 is connected to 8, 2 is connected to 7, 3 is connected to 6. You're getting it?
Yeah.
This is roll or rollover.
Okay, this is okay.
This is crossover. Yeah, crossover. Crossover is transmission bit is connected to receiving bit. Transmission 2 bit is connected to receiving bit. Receiving bit is connected to transmission bit. Receiving bit is connected to transmission. Straight through is transmission is connected to receiving with through the at the same level 1 to 1, 2 to 2, 3 to 3, 6 to 6. But in crossover you will have 1 to 3, not 1 to 1.
Yeah.
1 to 3, 2 to 6, 3 to 1, 6 to 2. This is rollover.
This one is straight. This one is.
Yeah, crossover. This is rollover. In order to understand it, just remember this. Straight through will be 1 to 1, 2 to 2, 3 to 3, 6 to 6. Crossover will be 1 to 3, 2 to 6, 3 to 1, 6 to 2. And rollover will be 1 to 8, 2 to 7. Rollover, complete reverse. And usually you do this in the interfaces. Actually, the cable will be same. But RJ45 interface, whatever the RJ45 we have, in that we clamp it in this manner.